Hey everyone, I just wanted to make a quick video to show you what I've been working on this week. I wasn't able to make the meeting since I am going to a work event up in northern Pennsylvania, but I wanted to keep you up to date. I was tasked with completing a Vortex generator that could be automated, and we could use excuse me on that, to make a more consistent ring. So before we had this, which was essentially a coffee can with a punch balloon on the back that we could make a vortex ring with. So this is the upgraded model. And basically what this is a piston cylinder with a valve on the end. This would be an intake valve that could eventually be controlled with a solenoid controlled by a computer. This would be the exhaust valve. So basically the intake valve would be opened, the piston would slide forward, and then the nozzle that I'll show you the disassembly of in a moment would allow the orifice to pass through. You can see right here currently we have just a standard cylinder, which is the interior of this, and then we could also expand it out to make it smaller, larger, whatever ring we wanted to test. This is a plug right now, but it would eventually be a line with an exhaust valve that would also be solenoid controlled. The idea would be to have the piston travel forward under pneumatic pressure, shut the intake valve, and then open the exhaust valve and allow the water pressure to atmosphere differential to force the piston back. And then we could shut the exhaust valve and the cannon would be ready to fire again. I may consider putting a spring in here to reset the piston, but I'll go ahead and disassemble this for you so you can see where we are right now. So right now, this is how we are going to have this so we can test multiple iterations of cone. So basically we have this insert right now. Oh, sorry, trying to get the angle here. Right now it's just a straight shot through, but we could taper this to make it whatever angle and size we want, up to about 2.5 inches is I think my limit with this design. So in here we have a insert that goes into this. In the bottom of this we have a rubber stopper. This is to absorb the impulse from the piston as it comes forward. And then in here we have our piston within the cylinder. So the outer is an 1.25 inch PVC pipe. This is 1 inch PVC pipe with both ends plugged. I've got O-ring grooves in this that allow it to seal better. Now the O-rings that are currently on here and this one I just did by hand with a Dremel, so there's a bit of blow by, but it works very well. I've already talked to the machine shop guys and Jacob about O-ring dimensioning, so next week I will plan to go into the machine shop and groove out these O-rings on a lathe, so we'll actually have a very good seal to minimize blow by. But basically this piston sits back, sorry this is kind of backwards on here, but sits back into here. When the valve is released it comes forward, compressing the water that's on the other side. When it comes through this nozzle it impacts into this washer that's got a rubber back on it to absorb the impulse, and then the water it displaces travels through this hole that's matched up to that. We can adjust the discharge to whatever diameter we want, and then I could extend this length out so it clears the end of this nozzle as well if need be. I haven't done that yet because I wanted to test sizing above everything else. But essentially that goes back into there. This will be press fit, eventually glued together. The plug drops in. This end screws on. That allows us to tighten up the inner nozzle, make it vary so it doesn't shake around. And then piston gets reinserted into here. There's just a little bit of grease on that, but I mean it slides very freely. Almost no resistance. If I was going to do a spring, I'd place it in here so it would be compressed up against that pad. Again, I would rather use water pressure to reset this, but depending on how this goes, that's the setup for the Vortex cannon so far. Again, intake and exhaust valves would transition to an airline off and be an electronically controlled solenoid, and then we could adjust the end for whatever type of discharge we wanted. whether a smaller or wider hole would give us a more optimum, and I could extend that insert all the way out if I needed to. I just have not done that in this initial print. So hopefully by next week I'll be able to have the final piston and with properly dimensioned O-rings grooved into it, and we should be able to test it. I have done a test on this where I did it in the bathtub and had my roommate film kind of the discharge, and we were able to see a good kind of conical shaped start to grow out of the discharge. It was a pretty low quality video, and I don't have it on image right now, but the plan would be by next week to, hopefully by the end of next week, to have the piston dimensioned or O-ring grooves put in properly. We could glue all this together with PVC cement, and then I'll use manual valves initially just for testing while I research some electronically controlled solenoids. Once those solenoid valves are found, actually you could tune in a frequency of pulses within, the restriction of the time it takes the piston to reset for the amount of frequency you'd like your disturbances to generate at. But that's the plan right now. Just wanted to make this video so everybody was kept in the loop, and I'll see y'all next week. Thank you.